Okay, let's continue our conversation with learning target number 2. All right, so what is going to happen to the acceleration if we have twice as much force and the mass is twice as much? So force is equal to mass times by acceleration. If I want to look at acceleration, force divided by mass equals acceleration. So if I double this and I double that, then the acceleration would remain the same. Okay? Now, what if I had half of the mass as before? Okay? So we have forces remaining the same, but our mass is half as much as it was before. That would double our acceleration because they're inversely proportional. When this got small, that would get big. All right. So when we come across these kinds of problems, we're going to analyze the problem, determine the system, and say, which direction is positives and negatives for a free body diagram, determine our knowns and unknowns, and then we'll use Newton's second law for acceleration. We'll rearrange the equation as we need it, and then ask ourselves, is this reasonable? So if the ball weighs 15 grams, and the two of you both push it in the same direction with a force of 50 newtons, what would be the acceleration of the ball? Okay, so our system here, we have our ball, we're saying this is the positive x direction, and then we have two forces acting on it, and you push in the same direction with a force of 50 newtons. So you have two 50 newton forces acting on this. Okay. Determine the knowns and the unknown value. So our free body diagram here, we have force 1 and then force 2. So the sum of our forces would be force 1 plus force 2. So 50 newtons plus 50 newtons, we have 100 newtons of force. Okay, so we recognize our knowns. We also know the mass. So sum of the forces is equal to 100 newtons. Mass is equal to 15 kilograms. Acceleration is what we're solving for. So now let's use that equation. The sum of the forces is going to equal mass times by acceleration. Or the sum of the forces divided by mass will equal acceleration. So let's just plug those in. 100 newtons divided by 15 kilograms. Okay, so I plug that in. 6.666, etc. We have 1 sig fig, 2 sig fig, so I'm going to round that up to 7. And then units of acceleration is meters per second squared. But let's do a unit analysis to see if we do in fact end up with meters per second squared. We took a Newton and we divided it by a kilogram. Okay. Newton divided by a kilogram. A Newton is a kilogram meter per second squared. Okay. And then we're dividing that by a kilogram. And put that over 1. So the last thing here, we have our Newton, kilogram meter per second squared, multiplied by the reciprocal, so 1 over kilograms. So those cancel, and we do in fact end with meters per second squared. Right, so that final answer there, acceleration 7 meters per second squared with that kind of net force acting on it. Free fall motion. So let's review this quickly. First, the acceleration of an object in free fall is the acceleration due to gravity. And so that's 9.81. And I went through, I changed it on the slides. I forgot to change it in your notes. So 9.81. Now, if we're calling going down towards the Earth negative direction, then that acceleration would be negative 9.81 meters per second squared. So what we mean by this is after 1 second, its velocity will be 9.81 meters per second. And after 2 seconds, its velocity will be double that, 19.62 meters per second. Every second the velocity increases, we add another 9.81 meters per second. Okay? So it's that change in rate of the velocity. And we can use this information in our kinematic equations, and we have been doing that. So we have a roofer accidentally drops a roofing tile from the roof. What is the velocity of the tile after 4 seconds? Okay, so we have our tile that's dropped from the roof. I'm going to choose, and just this is a quick reminder about kinematics, I'm going to say that this is my origin. Okay, so x initial would be 0, x final, we don't have that information. Velocity initial would be 0. Velocity final, that's what we're solving for. It says, what is that velocity? Acceleration would be negative 9.81 meters per second squared. Time initial is 0. Time final, 4 seconds. So I need to pick a kinematic equation that my only unknown is velocity final. So it can't have an x final as part of it. So let's see what we have here. Well, this one doesn't. That one has x final, so that doesn't work. So does that, so does that. So this is the equation that we need to use. And that's in your reference sheet, these lists of kinematic equations. So we have velocity final is equal to velocity initial plus acceleration multiplied by time final. Okay. So velocity initial was just 0. So velocity final is acceleration multiplied by time final. Acceleration is negative 9.81 meters per second squared multiplied by 4 seconds. Okay, when I multiply those, my velocity final, 3 sig figs, 1 sig fig. So my final answer will be 1 sig fig, negative 40 meters per second. It's negative because we've said that going down is the negative direction. So it makes sense that that velocity would be going down in the negative direction. Now it's asking how far will the tile fall in this time. So we can take this information of negative 40 meters per second, we can add that to our list here. Okay. So how far will the tiles fall? So we need to pick an equation where we're solving for x final. Okay. I like this equation, and I like this one because it's already rearranged for x final. Velocity initial is 0, so this whole component is going to drop out, and x initial is 0, so that's going to drop out. So this becomes a very simple equation. So I'm going to choose to use this one. But you could choose to use any of these, and you'll get the same answer. So I have x final is equal to x initial plus velocity initial multiplied by time final plus 1/2 acceleration time final squared. Okay. X initial is 0, velocity initial is 0. Anything times by 0 is 0. So those components drop out. So x final is equal to 1/2 acceleration time final squared. So this will be 1/2 times by acceleration, negative 9.81 meters per second squared, multiplied by time, which is 4 seconds, and then we take the square of that. Okay, so I'm going to take 0.5 times by negative 9.81 times by 4 squared, which is 16. And again, 1 sig fig. So this is going to round up to negative 80 meters. Now, this negative, let's ask ourselves, is that reasonable? Well, we established our origin to be the top of the roof here. And so we're going negative 80 meters from that origin, so that would make sense. That's how far the tiles will fall. Okay. On to the next page. A tennis ball is thrown straight up with an initial speed of 22.5 meters per second. It is caught at the same height above the ground. How high does the ball go? All right, let me check time here. Let's set this one up, and then we may have to finish it on the next video. So we have the tennis ball, someone's holding it, and then they throw it in the air, it goes up, and then it returns. And so we see, we want to know how high does the ball go. So that would be this point up here. It wouldn't be the returning point. So I'm going to call this my origin, where we started, and then that's x final up there. So we have x initial, x final, velocity initial, velocity final, acceleration, time initial, time final. I chose this to be my origin, so x initial is just 0. X final is what we're solving for. We want to know how high up does the ball go. Velocity initial, let's see, the tennis ball is thrown straight up with an initial velocity of 22.5 meters per second. That's 22.5 meters per second. What about velocity final? What would the velocity of the ball be right there at the peak? At that moment, right before it turns around and heads back to Earth. For just that brief moment, at its maximum height, the velocity is 0. And then it's going to become a negative velocity as it comes back to Earth. So we have positive, positive, then it stops for just that briefest of moments, and then it turns around and comes back to Earth. So my velocity final is 0 meters per second. Acceleration is due to gravity. There's no thruster or anything else acting on the tennis ball, so my acceleration is negative 9.81 meters per second squared. Time initial is 0. Time final, let's see if it provides that information. Nope, it doesn't in this one. So we need to pick a kinematic that does not include time, and the only unknown is x final. Okay, this one doesn't even have x final. That one has time, that doesn't work. This one doesn't have time, and it has x final, so that one, we could use that. We can't use this because of the time component. So this is the equation that we'll be using. So velocity final squared is equal to velocity initial squared plus 2 times by acceleration x final minus x initial. Okay, so that's where we're going to end this one, and then we'll wrap it up on the next video.